Hi again and welcome back. Let's talk about a real challenge for every utility: limited budgets versus unlimited needs. Imagine working at a water utility or a similar organization. There are always hundreds of asset needs repair or replacement, new development projects on the table, and high expectations from both customers and regulators for reliable, affordable service. This is where optimized investment planning steps in. The goal: choose the best mix of projects, get maximum value for stakeholders within the budget limits, and manage risk proactively. OPEX versus CAPEX, bridging the gap. You will often hear about two types of cost: OPEX, daily running and maintenance expenses; CAPEX, large investments for new or replacement assets. Good asset management teaches us not to see them as rivals. Spending a little more on CAPEX, like increased preventive maintenance for pumps, can delay big CAPEX outlays, such as major replacements. On the flip side, a smart capital investment can drastically cut future operational costs. For example, investing in modern, energy-efficient pumps may have a higher upfront cost but can save on electricity and repairs years after year. Principles of optimized investment planning. Let's break down the core principles. Strategic alignment. Every project should advance corporate goals, saying safety, reliability, and cost effectiveness. Risk-based planning. Rank projects by how much they reduce risk or deliver value, not just by cost or who's asking. Lifecycle consideration. Use tools like LCC, lifecycle costing, to capture cost and value from acquisition to retirement, not just the first check. A stakeholder balance. Don't forget the often conflicting needs of customers, regulators, staff, and the environment. Effective planning finds harmony between them. Investment planning process. Here's how the process works step by step. Needs identification. Which assets are nearing end of life and where are the biggest risks in the network? In flood-prone areas, this may mean prioritizing assets that would fail first in an emergency. Options development. Multiple solutions are explored. Should we repair, replace, upgrade, or switch to a new technology? For instance, rebuilding a pump station versus converting into solar power. Option analysis. Analyze using LCC, risk analysis, and multi-criteria decision models (MCDA) to see the long-term trade-off. Sometimes environmental and social benefits outweigh cost alone. Prioritization. Projects are ranked and packaged into a portfolio, not chosen in isolation. For example, a 5-year plan may mix critical renewal with the strategic upgrades, approval, and budgeting. The strongest projects move forward into capital budgets subjected to board or management approval. Sometimes creative phasing, doing part of a project now and part later, helps fit more within a budget which is tight. Review and updates. Circumstances change, sudden floods, new regulations, or even updated asset condition data. Plans aren't set in stone. They are reviewed and refreshed regularly. Decision tools and methods. Portfolio management. Sync team sports, managing the mix of projects for best overall outcome, not just picking star players. Decision frameworks. Structured methods like AHP, analytical hierarchy process, or scoring models help compare projects on a level playing field using numbers, not just gut feelings. Scenario planning. What if population growth is suddenly faster or climate change brings more droughts? Running scenario tests your plan's resilience. Optimization models. These mathematical models, like integer programming, dig through all project combinations and constraints to find the most balanced portfolio, a bit like solving a complex puzzle. Suppose over the next 5 years, a water utility considers 3 major projects. A. Replace a main city pipeline, $50 million. B. Upgrade a water treatment plant, $40 million. C. Build a new storage tank, $30 million. But with only $80 million budgeted, not all can go ahead. Asset management principles tell us to look beyond just cost. Project A slashes social operational risk by preventing large-scale outages. Project B satisfies regulatory demands, dodging stiff fines and protecting health. Project C addresses growth, preparing the city for the future. Often the first two, A plus B, are selected because once C is valuable, it carries less critical risk in the immediate term. These kinds of trade-offs happen in every well-running utility, and open communication about why behind decisions builds trust with the stakeholders. Linking to ISO 55001 and SAMP. ISO 55001 doesn't just encourage risk-based investment, it requires it. Plans should demonstrate clear risk analysis, full life cycle costing, and alignment with big picture strategy. The SAMP or Strategic Asset Management Plan connects day-to-day project selection with these big long-term objectives, ensuring accountability. Common challenges and solutions. Investment planning isn't all smooth sailing. Political pressure may try to push pet projects to front of the queue. Hazards like floods and droughts can change priorities overnight. Asset data may be incomplete, maybe due to the legacy records or gaps in digital monitoring. It's tough to compare projects that deliver social value like improving community trust versus those delivering strict financial returns. Successful organizations tackle these with transparent decision frameworks, better data collection, and regular, clear dialogue with all stakeholders, customers, regulators, and staff alike. Optimized investment means choosing the very best mix of projects within budgets, using risk, value, and lifecycle costs as your guide. It's a dynamic, evidence-based process, from identifying needs, developing and ranking options, through to regular review. ISO 55000 and SAMP provide a map to navigate challenges and keep investment decisions strategic, fair, and sustainable. In our next session, we'll explore how to measure asset performance and use KPIs to track our success in asset management. Thanks for joining. See you there.